morning students. We have seen chemical kinetics part 1, what is order, what is rate of a reaction, what is meant by molecularity, these all parts we have covered, how to write the rate expression or rate law of a particular reaction, these are all things we have covered in part 1. This is part 2. In part 1, I want to tell you something. In the sense, part 1, I want you to do some homeworks from the textbook. Always, as you know, your prime reference is your textbook. So, you need to do homeworks from textbook NCERT exercise 4.2, 4.3 and examples 4.3, 4.4 in page number 100 and 101, index questions 4.3 and 4.4 in page number 103. Clear to you? NCERT exercise 4.2, 4.3, example 4.3 and 4.4 in page number 100 and 101, index question 4.3 and 4.4 in page number 103. As you all know, I am Sindhu Nair, PGT Chemistry from KVNAD Karancha, continuing with the part 2 session of chemical kinetics. Students, what all things we are going to discuss? It is listed on the board, elementary and complex reactions. This was a 1 mark question. Earlier it was asked in board examination. Now also in 2009, 2010 and all papers you can see this question. What is meant by an elementary reaction? A chemical reaction proceeds in a single step. That's called an elementary reaction. A chemical reaction which proceeds in a single step, which is called an elementary reaction. And a chemical reaction which takes place in several steps, which get completed in several steps, that is called a complex reactions. This case you see, this first reaction, reaction 1, and this is reaction 2. This is an elementary reaction where the reaction takes place in one step. So, this will be the rate determining step. This step will be used for determining the rate of the chemical reaction. The second reaction which I have written, hydrogen peroxide reaction with iodine in alkaline medium to produce water and oxygen. This takes place in 2 steps. First step, hydrogen peroxide react with I minus to produce H2O and IO minus ions, which further react to produce H2O, I minus and O2. So, this takes place in 2 different steps. So, this is a complex reaction, a chemical reaction which takes place in more than one step, which is called a complex reaction. In this case, there will be a question, you always will have a question, which will be the rate determining step, how we will determine the rate. In a complex reaction, which is the slowest step? Out of this, which step is the slowest step? That step will be the rate determining step. Hope it is clear to you. Now, it comes to pseudo first order reactions. For example, hydrolysis of any ester, especially ethyl acetate COCH3, methyl acetate in presence of water. This is hydrolysis, little sulfuric acid is needed. This reaction, you will get acid and alcohol, as you know, CH3COOH and CH3OH. This reaction, if I write the rate is equal to concentration of K into concentration of CH3 into concentration of H2O. This is naturally the rate expression. If I write the order seems to be 1 plus 1, that is second order reaction, but the reaction is first order because the concentration of water, normally we take it as unity. The concentration of water in excess involving reactions, we take the concentration as unity. So, though it appears to be a second order reaction, it is a first order reaction. So, the reaction is called as a pseudo first order reaction. The reaction follows first order kinetics. Is it clear to you? Reactions which appears to be second order but follows first order kinetics. Such reactions are known as pseudo first order reactions. Okay, clear to you? Now, I come to integrated rate expression for 0 and first order reactions, which are sure questions in your annual examinations, either numericals from it or how to derive the integrated rate expression. For a first order reaction, how to derive the integrated rate expression? First, before coming to first order reaction, I will derive the rate expression for a 0 order reaction. See, we are deriving the integrated rate expression for a 0 order reaction. As you know, for a zero order reaction, rate is independent of concentration. Consider a reaction where reactants giving products. If I write the rate expression, dr upon dt is equal to K into, this is rate, na? Rate is equal to K into concentration of R raised to 0. This is rate is equal to K into R raised to 0, where dr by dt is rate is equal to K into concentration of the reactant raised to 0. This, as you know. This case, here I have to write the negative sign. What does it indicate? It indicates that the amount of concentration of the reactants keep on decreasing. Now, I have to, if I write it, minus dr upon dt is equal to K, because R raised to 0 is 1, A raised to R raised to 0 is 1. So, this term become K, or I am writing minus dr is equal to K into dt, or I can write dr is equal to minus K into dt. This equation I am putting number 1. On integration, integral dr is equal to integral K into dt minus. As you know, integral dr is R. K is a constant, so K integral dt minus K into t plus I, where I is called constant of integration. Integral dr is R, integral minus K dt, K is a constant, so it will come out integral dt hoga, so that integral dt is t plus I, that is constant of integration. To find the value of I, this I am remembering as equation 2. To find the value of I, suppose the initial concentration of the reactant is R0. If time 0, R is R0. Time 0, what is the meaning of time 0? When the reaction just begins, we take the time as 0. R is the concentration of the reactants, which will be taken as R0 in the beginning of the reaction. The concentration is R0. Suppose in the beginning at 10 o'clock we have started the reaction, we have taken 100 gram of the reactants, R0 is 100 gram. Beginning, the time is 10 o'clock, that is your time is 0 in the sense, does not mean the time is 0, the time with which the reaction starts. This is initial concentration, where R0 is initial concentration. This is initial time, you need to understand that, initial time. So, here I am putting the value in equation 2. If t is equal to 0, R is equal to R0, equation 2 become, how to write? R is equal to, R0 is equal to, R become R0 minus K into 0 plus I, that is I is equal to R0. This term becomes 0. Put the value of I in equation 2. Put the value of I in equation 2. So, you will get R is equal to minus K into T plus R0. This is in the form of a, this is the equation in the form of a, means this is equation for a straight line, y is equal to mx plus c. So, if I plot it, y means R versus R0 will be, I mean R versus T, y versus x na, R versus T will be a straight line having slope minus k. Yes, slope minus slope is k, I should write like that, and intercept R0. If y, this equation y versus x, this is the slope and this is the intercept. That case, R versus T minus K should be the slope, or minus slope will be K, both are same, and R0 will be the intercept. I am continuing here, you can see. Here you can see, I will number it as 1, 2, 3 columns so that you will get the continuity. This is column number 1, this is column number 2, again here it comes column number 3. So, then now you see from equation 3, this equation I am numbering it as equation 3. From equation 3 you can see R0 minus R is equal to K into T, or K is equal to R0 minus R upon T. Is it clear to you, children? So, K we have derived a relationship between the rate constant of zero order reaction, initial concentration, concentration after time t. R is concentration after time t. If you are given initial concentration and concentration after a particular time t, you can calculate the value of K. Now come to the term half-life. Half-life, yeah, T half indicates the time taken for half the chemical reaction to complete. Time taken for half of the chemical reaction to get completed. Suppose you have taken 50 gram of the reactant, the amount should become 25 gram, initial time was 0 or 10 o'clock, 10 am. How much time taken for 50 gram to become 25 gram? The amount of reactant took how much time to become half of the initial concentration, which is called a T half. Yeah, it is called a half-life. The time taken for the reactant to become half, that is called a half-life. So, suppose the initial concentration is R0, time is T, when time is T half, means half the time, your reaction is under observation for half an hour, means 15 minutes, that is half time. Half the time, the concentration will be, R0 by 2. Initial concentration is R0, time was T, when time, suppose the time is 20 minutes, initial concentration was R0, when time become T half, 10, the concentration will be half of R0, naturally, T half. Substituting this in this equation, this is for your convenience, I have told like this. Substitute this value in this equation, K is equal, this I am numbering it as 4. From equation 4, K is equal to R0 minus, when time is T half, what is R? It is R0 by 2, means R concentration is R0 by 2. When time is T half, R is R0 by 2. Now, I have to write like that. So, it is equal to R0 minus R0 by 2, that is half R0 by T half, or T half is equal to R0 divided by 2K. It is R0 upon 2K. I hope it is clear to you, children. T half is equal to R0 upon 2K, means T half is depend upon the initial concentration of the reactants, or K is equal to, from this K is equal to R0 upon 2 T half, means rate constant depend upon half-life and initial concentration of the reactants. Is it clear to you, children? Once again, you can go through the derivation because the derivation is very important. Reactant giving product, This reaction, I am writing the rate. I am writing the rate as dr by dt because R is a reactant. Then K into R raised to 0. This is a rate law, a rate expression what we write. Rate is equal to K into reactant raised to 0. Rate I have written as dr by dt. Reactant raised to the power raised to 0. dr by dt is equal to K into R raised to 0 is 1. So, it is equal to dr by dt is equal to K naturally. Here you see I am integrating this expression by placing dt with K. Integral dr minus sign I have shifted to the other side. Integral K into dt. Integral dr is R as everybody know. Integral K is a constant, so it cannot be integrated. Integral dt is t, so it will be kt plus I, that is constant of integration. This is rule of integration you have studied in maths. To find the value of I am writing at t is equal to 0. Initial time, the initial concentration R is R0. So, if I put in this equation, R0 is equal to K into 0 plus I, means I is R0. Got it? Now, you see I am putting the value of I in this expression, so that I will get R is equal to minus K into T plus R0. I is R0, of course. So, putting the value, I will get this equation R is equal to K minus K into T plus I is R0. Hope you got it. This is the equation of a straight line. Y is equal to mx plus c. This is c, which is intercept. If I plot R versus T, it will be a straight line. Having slope, minus slope will be K and intercept will be R0. It is clear to you? So, from this expression, I am taking R to that side, so that KT will come this side, it will become positive. R0 minus R is equal to KT, or K is equal to R0 minus R upon T. So, this is expression for rate constant for a zero order reaction. R0 minus R upon T is equal to K. Now, we will come to T half. T half is the time taken for half the amount of reaction to complete. Means 50 gram you are taking, how much time taken for the reactant to become 25 gram. That is what is called a half-life. So, if suppose initial concentration is R0, the time is T, initial time I have taken as T. At half time, when time is T half, R is R0 by 2, because of course R0 become half. I am putting this value in equation, equation number 4, K is equal to, if the initial concentration is R0, at T half, R is R0 by 2. R I have to write as